Hello guys. Okay, my name is Harrison, and today I'm going to teach you salts. It's in chemistry form two. I believe now you're in term three, and term three is the most sensitive term because you're gonna finish your syllabus. And today I want us to maybe talk about or talk more about salt. And you must know that. Salt is one of the most important topics in chemistry because it involves or it introduces you to maybe writing a lot of equations, and you have to know how to balance these equations and write them well so that you can form the salts and the different types of salt that we're going to talk about. So the first thing that I want us to learn, or I want us to understand what is a salt. If somebody mentions somewhere a salt, what comes in your mind as a chemistry student? So those are the questions that you must ask yourself. So a salt. The definition of a salt is basically a substance that is formed when a hydrogen ion in an acid is wholly or partially replaced by a positive ion. So assume that you have an acid and you have a positive ion. So I believe in term one you learned about the structure of atom and the periodic table, and you were taught on what is an atom. The definition of an atom, what atoms entail, the atomic radius, the mass number, etc. So for now, you must know how to apply this knowledge now, because here we're talking about a positive ion. You must I believe you know what's an ion, what is an atom. So here a positive ion is introduced in an acid. Let us take an example of HCl. HCl is an acid. So maybe the basicity of HCl um, is it's a monobasic. Yeah, it has one hydrogen ion because so it's a monobasic. So if you don't understand what is basicity is basically the ability of an acid or the ability of hydrogen ion to be released in an acid when it is ionized. So HCl can only release one hydrogen ion. Okay, so when a positive ion is introduced in HCl, so that positive ion will replace this hydrogen ion in HCl, because the tendency of hydrogen being released is very, very high, because we talk about the basicity, and I've defined basicity, the ability of an acid to, the ability of a hydrogen ion to be released by an acid when it is ionized. So that atom, that positive atom, let us we have different maybe we have a lot of positive ions. So these are metals. Okay, so metals, they do lose electrons to become stable, so they form a positive ion. For example, sodium. When sodium is introduced sodium is introduced in HCl, what will be formed? So we will have the sodium is a positive ion will replace the hydrogen, and then we will have sodium chloride. So very, very simple for you to define a salt. A salt is a substance that is formed when a hydrogen ion in an acid is wholly or partially replaced by a positive ion. So we can have, maybe let us see, we can have, let us now use another acid maybe. We can have H2SO4, that is sulfuric acid. So sulfuric acid is it's diabasic because it has two hydrogen ions. So the hydrogen ions that are supposed to be released by sulfuric acid are two. So let us now, introduce a positive ion. A positive ion. So when we introduce a positive ion, So that ion will partially replace the two hydrogens, because it will not wholly replace the two hydrogens, because I mean the positive ion is only one. So when it is when it is introduced to HCl, so it will only replace one hydrogen ion which has been released by that acid. So that is why we will find we have different types of salts. We have normal salts, we have acidic salts, we have basic salts, we have double salts. So we will talk about this as we go on. So I've already mentioned most of the things that you're supposed to know. We have defined what is a salt, and we'll say that it's a substance that is formed when hydrogen ions in an acid are wholly or partially replaced by a positive ion. So we also talked about the types of salts. So we have normal salts, and you must know the definition of a normal salt. So a normal salt is a salt that does not contain any replaceable hydrogen ion. So I mean hydrogen atom. So when we form a normal salt, I've explained that we have an acid, and this acid is supposed to be the hydrogen in the acid. I mean, they're supposed to be wholly replaced. So for us to form a normal salt, because the definition of a normal salt is a salt that does not contain any replaceable hydrogen atom. So the acid, I mean the hydrogens in the acid are supposed to be wholly replaced. We also talk about we have the examples of normal salts. We have like sodium chloride. Sodium chloride does not have any hydrogen atoms in it, and we also have potassium sulfate. So we have potassium sulfate. Potassium sulfate also does not have any traces of hydrogen in it, and we also have sodium carbonate. Sodium carbonate is formed from carbonic acid, so we don't have any traces of hydrogen in it. And we also have calcium nitrate. So calcium nitrate, we don't have any traces of hydrogen in calcium nitrate. That's making it a normal salt. Let's now talk about acidic salts. So as acidic salts, these are salts that contain irreplaceable hydrogen atoms. So uh, I will still take you back to the definition. The definition is, stating very well that, the hydrogen ions and acids are wholly or partially replaced by a positive ion. So underline the word wholly and or partially. So it means that these hydrogens can be wholly or they can be partially replaced. So in acidic salts, the hydrogen ions, they are not wholly replaced. That's why we have some traces of hydrogens ion in the in acidic salts. So they contain those replaceable hydrogen atoms. So some examples of acidic salts are sodium hydrogen carbonate. So because of the hydrogen in it, we call it an acidic salt because it has some traces of hydrogen from the acid. So that's making it an acidic salt. So it means that it is also formed from carbonic acid, and we introduce sodium in it. Sodium is a metal in group one. So the one sodium has only replaced one hydrogen atom in and carbonic acid to form sodium hydrogen carbonate, making it acidic because of the trace of hydrogen in it. So we also have potassium hydrogen sulfate. So from sulfuric acid, we have formed potassium hydrogen sulfate. So we also have here the trace of hydrogen in it, so that's making it an acidic salt. And also have sodium dihydrogen phosphate. So sodium dihydrogen phosphate. So di means we have two hydrogen ions in it. So it is formed from phosphoric acid, and you know the basicity of phosphoric acid is tribasic. Yeah, it has hydrogen, eight, three hydrogen ions in it. So I want you to go back and master the basicity. and I defined basicity for you. I told the basicity is the ability of acid to, the ability of a hydrogen ion to be released by an acid when ionized. So these salts, they have acidic properties to the presence of the replaceable hydrogen ion. So it's very, very simple for you to understand that. Now I want us to go to the third type of salt, which is basic salt. So basic salts are salts that contains hydroxyl ions. So the hydroxyl are the OH ions, the OH ions. So these salts, uh, it is the presence of the presence of the hydroxide ions that that is responsible for the basic properties of these salts. So the OH ion. So OH is basic. Hydroxide is basic, like the water that we should take has the OH group, and this OH is basic. So some of the examples we have magnesium, basic magnesium chloride. So basic magnesium chloride. So it has the OH in it. So thus it will be written as Mg OH into bracket Cl. So Mg the chemical symbol of magnesium, and then OH is the hydroxide ion, and then we have Cl as the chlorine atom. So we also have basic lead 2 carbonate, basic lead 2 carbonate. So when you're writing this, you must be very, very careful, because the next time I'll be teaching, I'll be using whiteboard marker so that I can show you how we're writing this. Very, very simple for you to write. So basic lead 2 carbonate. So in this basic lead 2 carbonate, you must realize that we have a radical in it. So carbonate, and we talked about the radical. Or you know what is a radical? A radical is a group of atoms with a net charge that exists and react as a unit. So group of atoms with a net charge that exist and react as a unit. So these atoms, they are existing and reacting as a unit. So it means when you're writing this formula for basic lead 2 carbonate, you must react a radical as a unit. So the radical will react with the hydroxide ion. The lead, which is the metal now, will react with the hydroxide ions, and then after that, it will react with the radical. So how do you write this? So it will be the lead carbonate, the lead hydroxide first, lead hydroxide, and then you just separate it with a dot, and then dot lead carbonate. So that is how you will maybe write your the formula of lead to carbonate. So I believe you have your book there. You can practice and see how you can write. And I want you to master what is a radical, and know how you can understand more of the radicals and their valence electrons. So we have, or their charge to be precise. So basic zinc chloride, basic zinc chloride, basic zinc chloride. So we don't have a radical here, so we'll just write it as normal. So it will be zinc, and then we have the OH at the beginning, and then the chlorine at the end. So we also have basic copper 2 carbonate, copper 2 carbonate, copper 2 carbonate. We have radical there, and I've told you you must write this as separate, and you will separate it with a full or a dot to be precise. So that is how that is how you can write all those chemical symbols, and it's very, very simple for you to do that. So we also have double salts, double salts. So double salts, these are salts in which there are two different anions and cations. So double salt, this is the last type of salt that I'm going to talk about today. I've started with the types of, defining what is a salt. And I believe you're very, very comfortable in defining what is a salt. And we have talked about the different types of salts. We've talked about the normal salts. We've talked about the acidic salts. We've talked about the basic salts. Now we are talking about the double salts. And I've told you, double salts, these are salts in which we have different anions that we have, there are two different anions or cations. So examples, we have the hydrated potassium sulfate, hydrated potassium sulfate. So we also have a radical here. You must be very, very careful in how you are writing this. So the hydrated potassium aluminium sulfate, let me just correct on that, hydrated potassium aluminium sulfate. So hydrated, it means it has water of crystallization. So what is water of crystallization? So this is the fixed amount of water incorporated within the crystal structure of a solid. You must know that. So in chemistry, you must understand from the word go, you must understand everything. Chemistry is a science, so it's mutual. You must know what is happening. If somebody talks about water crystallization, you must be able to define water crystallization because it can come in exam. Define water crystallization, and when you want to understand things, you must know what is that. So you know what is water crystallization. So when they're talking about hydrated potassium aluminium sulfate, you'll be able to write that. So on my next video, I will teach you how to write this and how to come up with these formulas very easily and balance them in a very, very good way. We also have hydrated ammonium ion 2 sulfate. It's also it is also, it is also a double salt. It has water of crystallization, that is 6 more water crystallization. That's 6 water of crystallization, and we also have the trona. So on my next video, I'll teach you how to write all those. So that is it for today, guys. See you on my next video. Bye.